Okay, Assalamualaikum and good afternoon, everyone. How are you today? Okay, so this is chapter 9, my slide. Okay, so in this chapter, we're going to discuss about a control valve and a transmitter, and also a little bit about calculation. Okay, so I try to go very slow. Okay, so before we go into detail about chapter 9, why don't we do some revision? Okay, so this is a standard block diagram of a feedback control system. Okay, feedback control system, just like I already draw it for you in another video. Okay, so this is called block diagram. Okay, because this is the the symbol. Okay, because it is in the block form. Okay. So, in chapter 8, okay, you already learned here, which is the controller. This GC is a transfer function. Okay, later on, for the next chapter, we will learn more about this transfer function. Okay, last time when you learn transfer function, you learn the transfer function for a process. Okay, so here we have a transfer function for a process that represented by this GP. Okay, and then you learn about PID is here. Okay, so the transfer function for controller is named as GC. C is for the controller. Okay, you learn about PID controller here. Okay, and then to complete our block diagram, we will learn in this chapter our control valve, our transmitter. Okay, so G is a transfer function. Transfer function. Okay, so P for the process. Okay, P for the process. V for the valve. M for the measurement. T for the controller. D for the disturbance. Okay, so the transfer function for the disturbance and a process can be the same, can be a different transfer function. Okay, so to complete our feedback loop, okay, we have to learn about, you already learned about controller. Today, in this video, we learn about transmitter and control valve. Okay, so uh, to start with, everything is start with a process. Okay, when you have a process, regardless any process, okay, from that process you should determine what is your control variable, what are the control variable, what are the manipulated variable, and what are the disturbance variable. Okay, from having that, you can move to a sensor. Okay, in my previous video I did mention that a sensor, why we need a sensor, because we have to measure our control variable. Why we need to measure it? Because we want to control it. We want to know whether it is high or low, and we want it to be at a specific value, which is a set point. Okay, that's why we need a sensor. We have to measure. Why we need to measure? Because we need to know. After knowing it is high, it is low, what is the value of that control variable, and then we can manipulate the manipulated variable so that the control variable will change accordingly. Okay, so you need a sensor. Okay, if you have a temperature as your control variable, you will need a temperature sensor. Okay, so transmitter here, okay, a sensor you cannot directly send to a controller. Cannot. Why cannot? Because it is in degree C. But the controller, this controller is an electronic device. It only can receive a signal in milliampere. Okay? So you need a transmitter. You need a transmitter, okay, to convert from here to here. Okay? That is the function of transmitter. Convert a signal, to convert and transmit the signal that came from a that came from a sensor to the controller. Okay? And then from a controller to the final control element, you need another component, another device that named transducer. Okay? So this transducer again will convert the value of output from the controller and give it to the final control element. Okay, so from previous video you have watched, you have already known that there are several types of control valve. Okay, and commonly used and the most widely used is a pneumatic control valve. Okay, why it is better than hydraulic and electronic? It is because low maintenance and it have a long operating range. You can use it for a long time. So this controller will send a signal to a control valve whether to open or to close. But this signal again in the form of milliampere in this unit. But for the final control element, which is the control valve, it only can receive a signal in the form of pressure, which is in this unit. That's why the transducer play an important role here, which is to convert from milliampere into the PSIG. Okay, and then another important, not to say important actually, quite confusing. Okay, but don't get confused. Okay, a transducer also is a combination of a sensing element and a transmitter, also named as a transducer. But for me, it's easier to say that the function of transmitter and transducer is about the same because it's convert from one form to another form. Okay, for this transmitter from degree C into milliampere. For this transducer, this milliampere into pneumatic. Okay, you can rewatch the previous video as that man can explain better than me. Okay, about what is a transducer and a transmitter. But in a simple word, it just a convert, it just to convert a signal from any form of signal so that the controller can receive the signal. Okay? Remember that the controller is an electronic device. Okay? It is an electronic device that only can receive electronic signal. Okay. Okay, so this is one of the example. Okay? It's different from your previous one. The previous one you only have a blending process, but here we have a heating process. How do I know it is a heating process? It is basically have a heater here. Then from this heating process, it involves energy balance and mass balance. Okay? So if you want to create a dynamic model for it, you have to take mass balance and energy balance together. Okay? So the dynamic could be dt over. Okay? So here, as I said previously, the first one we should have a process. So we have a process here. which is a heating process. We have a tank that liquid flowing into the tank at a specific temperature, initial temperature, and then a heating process occur in this tank, and at the same time the uh, liquid flowing out from that tank with our with a temperature as our control variable. So because of the temperature is our control variable, what we need is a sensor. The first one is a sensor, which is basically a thermocouple. This is one type of a sensor, thermocouple. It's convert the temperature of a liquid into millivolt signal that can be received by the transmitter. And because of that, before sending to a controller, we need a transmitter. Okay, we need a transmitter here, TT, temperature transmitter. It will convert and it will amplify the voltage level so that the controller will get appropriate level of voltage from the sensor. Okay, and then of course we need a controller. Okay, so since this is a temperature control system, so we need a temperature controller here. Okay, so from this temperature controller, what did this controller do? It will compare the value of PV, process variable, to the value of SB. Okay, that's why last time you see the plus minus but block in a Simulink, the plus and minus block, because of the we set the value here, and this is the current value, and how much the difference, which is the SB minus PV, is equal to how much the error, and that is also how much the corrective action should be taken by the controller, since this is a feedback loop. So from the controller, it will convert back into electrical signal, so that this heater will be heat up. Okay, it will convert the energy from electrical energy and turn it into a heat. Okay, so here we have a final control element. Okay, final control element here is the heater. Okay, it is not a control valve. Okay, so the final control element, okay, what is the definition of final control element? It is a device that manipulate the manipulated variable so that change the process. Okay, you can refer to the definition later. I also don't like to remember or memorize the definition, but I do understand that this final control element is very important, because this control element will change the manipulated variable so that the control variable will achieve a set point. Okay. So moving on to the next, okay, we have also a transducer. People keep on confusing. I also confused what is transducer, what is a transmitter, and also people keep on interchange between these two. But in a simple word, what I can say, both of it change a signal from one form to another form. Okay, so we have your the previous example that you have. It is a blending process. Okay, it's only involve mass balance. Okay, for this one is involve energy balance and mass balance. Okay, because later on, if you can see your previous partial equation, you will be given a diagram like that, like this. Okay, you will be given a diagram like this, and then you have to develop a dynamic model for this particular process. But that was the last time lah. This year I don't know. Okay, uh this is dt over dt. This one should be dx over dt, right? Okay, so here we have a control valve. Okay, this is a symbol of control valve. This is basically PNID. Okay, if you can remember, this is a PNID diagram, process instrumentation diagram. And then here we have a heater as our final control element. Okay, in terms of transducer, okay, here we have current to pneumatic. Okay, current to pneumatic transducer, whereby it will convert the output of controller from milliampere into uh, pneumatic. Okay, commonly it's 3 to 15 psi. Okay, this is a standard range used worldwide. Okay, in fact, in your lab also use this range. Okay, so that's it about a transducer. So move on to a transmitter. This is the all the definition. Okay, we have three important thing in transmitter, whereby the first one is the range or span. Okay, I did explain because I make a separate video. Maybe I will combine. It will be a later in this video, but I did make it separately actually. Okay, so the first one is the range. Okay, so for the transmitter to work, it have a specific range. There is no transmitter that can work with a very huge range. Okay, it must have a specific range. For example, this one. Okay, this temperature transmitter having a range of 50 to 150 degrees C only. Okay, below than that it cannot be it out of the range, and maybe there's nothing happen when you maybe not maybe the transmitter cannot transmit the signal that out of from its range. Okay, so if you are given this information, okay, I already put it in another video. Okay, so there are three important things for you to understand, and it also actually a calculation part for this chapter. Okay, so the detail in the next session. Okay, next video. Okay, so I also showing there on how to get this expression. Okay, this expression is basically a relationship of input and output for this transmitter. Okay? So for the transmitter, there are three main points that you have to understand. Okay, they are named as zeros. The second one is the span, and the third one is the expression or equation. Okay, so a simple question, just like I'm giving you this input and output information, and you find this value. You will be given this, have to find this. Okay, I did show in later video. Okay, and okay, this is a transmitter. Again, a transmitter. Okay, you will learn that this K is a gain, M is a measurement. So Km is a measurement gain. Last time you did learn about Kc is a proportional gain. Okay. So in process control, there are a symbol and a definition. Maybe I have to create another video on that. Okay. Explain to you the symbol and the definition of it, because later on we will using it a lot. Okay, in chapter 11 later on. Okay. Okay. For the measurement, and also this one I did explain in uh, that video. Okay, so I will just skip from now. Okay, so the transmitter. Okay, for this one, the relationship of input and output is linear. Okay, that's why you get this straight line. Whereas for there are also a non-linear instrument. but not really not commonly used. There are, but people always assume it to be linear because it also shows a linear behavior. Okay, don't worry so much. So this is a sensor. Okay, in detail you can get from the textbook. Okay, so this sensor might be useful for you in plant design later on. Okay. Okay, moving on to the control valve. I do believe that you already watched the video. Okay, and that guy explained about the control valve. I think his explanation is better than me. You can rewatch again. Okay, but what I will discuss here just a simple about the terminology of the control valve itself, the philosophy. Okay, failure philosophy. Okay. So there are two type of control valve, which is AO or AC. Okay? AO is air to open, AC is air to close. Sometimes people read it as ATO or ATC. Okay, so these two type of control valve have their own application due to the safety. Okay, so you can watch in the video for air to open valve as pneumatic controller output signal increase, meaning to say from a controller, let's say from a controller, it will send a signal to a control valve, right? Okay, I will put it as a GC, okay, and GV. It will send a signal to this control valve. If the signal increase, and then there will be increase in, okay, we already know that we need a transducer to convert the signal from milliampere into psi. Okay, when the signal increase, the psi also increase, so it will compress the spring of the inside the control valve and pulling out the stem out and opening the valve. The animation you have to rewatch again the video. Okay, and then for the air to close, it's reversible lah. Okay, so I want to skip that. Okay, so normally the selection of air to open or air to close is based on safety. Okay, we choose the way the valve should be operated, whether full flow or no flow, so that the system will be safe in case of transmitter failure. Okay. So as you are known, we have a feedback. Okay, we have a feedback. This is a GC. This is a GV, which is a transfer function, and we have a process. Okay, then we have a GM. Together with that, inside the controller, okay, could be another transfer function here. This block diagram is for the feedback. Okay, for the feed forward, it is another form of block diagram. But don't worry, your syllabus only cover the feedback. Okay, so in order for us to choose this control valve, okay, can we change the color? Cannot. Okay, in order for this control valve to work safely, we have to choose whether we want to use air to open or air to close. In case of a transmitter failure, the transmitter failure meaning to say this transmitter maybe something wrong happened to this transmitter. It could be not sending any signal. Let's say what happened is, sorry, okay, it's not sending any signal. Okay, not sending any signal. So this is open loop. Okay, and then this controller cannot compare the value of PV to the value of SV, and this controller will not do anything because you don't know here what is the value of error. Okay, in case of that, this valve should be open or should be closed. It depends on the safety. Okay, so if it is dangerous for the system, if we are using, okay, make it as fail open or fail close, fail close. Okay, before I forgot. Okay, air to open. Okay, when there are air. Okay, when there are compressed air, the valve will open. But when there are not, the valve will close. So this valve also known as fail close. Okay, one is fail open. Okay, so in case of later on we will see the an example. Okay, in case of the system, okay, based on the safety for the system, should be fail open or fail close. Okay, not fail to open. Fail to open. Fail to open is something else. Broken actually. Okay, fail open. Fail close. Okay, so it's depend on a situation. Okay, for example, if you have a hot steam flowing through this control valve, okay, when a transmitter failure, is safe to close or is safe to open? Okay, so we go straight away to the example. Okay, example 9.1. Okay, so for the first case is we have a steam pressure in a reactor heating coil. Okay, for example, here we have a reactor. Okay, I'm sorry, my drawing is not that nice. Okay, we have a heating coil inside this reactor. Okay, steam. This is steam, and we have a control valve here. Okay, a control valve is a steam. Okay, flowing through, it's flowing out. So this kind of control valve is safe to use fail close or fail open. What do you think? So the answer, oh no answer, giving you different situation. Okay, the example number 2, when you have a polymerization reactor, your reactant, so your control valve is here. You want to fail close or fail open. Okay, same goes with the third and the fourth one. Okay, let's see the answer. Okay, for the steam, it should be fail close. Why it should be fail close? Because when there are transmitter failure, the valve should be closed to prevent the steam from goes into flowing into the coil, so the overheat can be avoided. And then for the reactant flow into the polymerization reactor, the choice would be air to open, fail close. Okay, we want to close. Anything happen, the valve will close. Anything happen, or emergency situation, the valve will close. Okay, so it should be fail close because we want to prevent the reactor from being flooded with the excessive reactant. And how about this C? Okay, flow of effluent from wastewater treatment holding tank into a river. Okay, it should be fail close or fail open. It should be fail close also. Okay, because we want to prevent maybe any untreated waste. Okay, fail close. The when the first situation occur, and this is the feedback. Anything fail, the valve will close. Anything fail, the transmitter fail, or anything, any problem, the valve should be open. Okay, that is the meaning. Okay, and the last one is flow of cooling water. Okay, to the distillation condenser, you should use fail open. Okay, because you still want the cooling process to occur rather than stop the flowing. Okay, because if we stop the flowing here, the temperature might be increased. That is more dangerous. Okay, okay, I think this is the last slide. Okay, we're talking about transmission delay, transmission lags. What is this? This is a transfer function, right? This is a first order transfer function. How do you know this is first order? Because this is the power of 1. Okay, when you have a second order, okay, something like this is second order because of the power is 2. Okay, so for this thing, the location of the sensor, the material is very important because we try to avoid this transmission delay. Okay, and then for the pneumatic transmission line, there's no time delay, but no time delay less common today compared to cases about the transmission. Nothing so important. That's all from me. Thank you for your time. Okay, don't worry if you watch the first time you hear something, you might take some time to digest. Okay, take your time. Don't get overshoot. Make sure you have a shorter settling time and shorter rise time. Okay. Assalamualaikum and good evening, everyone. I was thinking that I should make a short video about calculation for chapter 9. Okay, so for chapter 9, we have a transmitter. This time I'm using a digital whiteboard instead of a physical whiteboard. Okay, this is a digital whiteboard. Okay, so for chapter 9, we have a transmitter. Okay, as you already watched in the previous video, the transmitter will convert a signal, okay, from one form into another form of signal. Okay, so for the calculation part, we're going to calculate, we're going to determine three important point, which is the first one is named as 0, second one is named as n, and the third one is the equation or the expression that relate input and output. Okay, so taking into example, okay, let's say we have a heating process. Later on, I will give my video about that. Okay, so we have a temperature in degree C, and then this transmitter will convert it into a electrical signal in milliampere. Okay, so from this transmitter have their own range of input and also a range of output. Okay, for the range of output, it is 4 milliampere to 20 milliampere. Okay, and for the input, for example, it is came from a thermocouple, which is a temperature sensor. So the input is from 50 degrees C to 150 degrees C. Okay. So for you to determine these three things, okay, based on given value of this, okay. So from the information of input range and output range, you should know how to determine these three things. Okay. So what we have to do is the first one. Okay. The first one is the zeros. Okay. The zeros means the minimum. Okay. Zeros mean equal to the minimum input range. Okay. Which equal to, in this case, it is 15. Okay. Go to zeros. Okay. That is the definition of zeros. Okay. Whereas for the just the definition like that. Okay. Don't ask me why zero, why not one. It just like that. Okay. Just accept it as it is, which is it is zeros. Yep. Okay. So how about the span? Okay. The span basically range. Okay. The span. Okay. Okay. Uh, SPAN, the span is equal to the range. Okay. Still about the range of input, which is here we have 150 minus 50. Okay. Don't forget the unit. We have 100 degree C. Okay. So the span, the zeros is 15 and the span is 100. Okay. I hope you get the idea. Okay. It's just the definition like that. Okay. And I did uh, prepare a exercise for you. Later on, you can try. Okay. Okay, I want to move it. Okay. So for the equation, for the third one is the equation. Remember last time during our secondary school, we learned about a linear relationship, linear graph, which have equation that is y equal to mx plus c, if you can remember that, whereby the m is actually the gradient of this graph. Okay? If you can remember lah. It's okay if you don't remember. Okay, just I want to show you. Okay, so in transmitter there are also a new thing. Okay, it's named km. Okay, this km, um the km is the measurement gain. Okay, the measurement gain. You have to be familiar with this k because later on uh, you will learn more about all the k value which represent the gain. Okay, last time when you learn PID, you learn about KC, which is a proportional gain. Okay, gain. Also, K is a gain. C for the roller. Maybe I have to make another uh, video, or I put it later on in this video. What is KC? What is KM? Okay, but here we want to solve for this number 3, which is the equation that relate between input and output. So in this case, to find the value of, don't get confused when I'm changing the color. The value of Km is equal to the value of M and is equal to the gradient. So if we have 2 points like this, can we calculate the value of gradient or the value of m, which is km is equal to, just put the output divided by, okay, smaller side. Okay, we cannot do this if we are using a physical whiteboard, but here we can use it. Okay, so what we have here, maybe another color. I don't know why I keep on changing the color. Okay, so the output, just put it 20 minus 4 divided by 150 150, oops, okay, minus 50, don't forget the unit, okay, milliampere and also degree C. So what do you get? Okay, you can press your calculator. Okay, because of this I was bought a new calculator because my old calculator is really old. Okay, so I get 0.16 milliampere over degree C. Okay, that is the value of km or m. Okay, so now because we want to find this equation, okay, we have to find the value of C. Okay, so how to find the value of C? Just take any of the point. Okay, maybe I will take 50 degrees C and 4 milliampere. So we try to find the value of C. Okay, just substitute y equal to 4. Okay, we can put it together with the unit, but don't get confused. 4 milliampere, and then we have the value of m, 0.16 milliampere over degree C. Make it smaller, move it aside. Okay. And x have 50 degrees C plus C. So what is the value of C? Give me the answer. Okay. So it's basically 4 minus 0.16 times 50. Okay. I got it as a negative 4. So what is the unit actually? What is the unit for C? It should be milliampere, right? Okay. Once you get the value of M and you get the value of C, so you can substitute directly. So when we have, okay, we can make it smaller, move aside, and it's quite interesting to use this whiteboard. Okay, what's this? I need this. So because we want to have this kind of equation, y equal to x plus c, and here is actually a temperature transmitter. Okay, because it's from degree C into from degree C. Okay, in degree C is a temperature, so we just put it as a temperature. Okay, in milliampere, the output, and 0.16 dollar. Okay, degree C. Then here we have x. X is also a temperature, but in degree C minus 4. Other side, okay, smaller, because I just want make it in just in one page. Okay, so this is the answer. Okay, yeah, I can write it properly. Okay, the equation is T in milliampere have 0.16 ampere over degree C. Should put bracket here. Temperature C minus 4. Okay, yeah. So this is the calculation for this chapter. Okay. So later on you can try, okay, by yourself. Okay. Uh, you can try by yourself, and you get different input and different output. Okay. So hopes you okay with this. Okay. Thank you for your time. Uh, I just want to remind you that you have to do a lot of exercise. It's just a really simple equation, but I did provide you the exercise, and you do it. Upload your what you are doing. Okay, I'm not. I don't want to burden you to do it. I don't. My intent. It's not my intention to give you a lot of work to do, but I have to ask you to send me what you are doing. No, you are not going to do that. Okay? Okay, that's all for this video. Thank you.